Hey, hey, hey! What's up, Webster Groves? This is the Wave Energy Goal 2 Notes for 8th grade science. In this goal, you are going to be able to identify media and sources of sound, describe how sound is transferred by waves. So doing those two things, also explain why sound cannot be heard in a vacuum. So here we go. How do sound waves travel through the air? Well, glad you asked, because let me tell you. The vibrations disturb nearby particles. It's important to note that you need a vibration. Each time the speaker moves to the right, it pushes air particles together, creating a compression. When the speaker moves to the left, the air particles bounce back and spread out, creating a rarefaction. These compressions and rarefactions travel through the air as longitudinal waves. So, what we have going on here, we have compressions, which are these areas right here, and then rarefactions, which are the areas in between. So really, these longitudinal waves still have wavelength, because we can measure between the compressions. And they still have amplitude, and they still have frequency, just like transverse waves. So this is how sound moves through a medium. It pushes the particles of matter. Those particles compress together and then spread out. What is a sound? Sound is a disturbance that travels through a medium as a mechanical wave with a longitudinal wave movement. Whoa, lots of vocabulary there. So a disturbance is the source, okay? Whatever is causing the disturbance, that's the source. That's what's causing the vibrations. It travels through a medium such as air, such as water, such as the microphone, whatever it's moving through. And then it is making a longitudinal wave movement. Now, I hope you're at the point where you can identify this as a longitudinal wave movement. This is what sound looks like. This is transverse. We have the disturbance going up and down, the wave moving back and forth. This is not what sound would look like. Disturbance for sound is going back and forth, and the wave is also going back and forth. Okay, so that's what you got for sound. That is the type. Type is mechanical. Movement is longitudinal. How does sound wave begin? Sound wave begins with a vibration. Whatever is causing that source of sound. It could be a clanging gong here, like we have here in this picture. It could be your vocal cords or your larynx. So whatever is vibrating, that's what is causing the sound. That's the source. The object causing the vibration is the source of sound. The word you need to know. There's a sound source. So this picture shows us what it might look like. Here in the middle we have the source, okay, and that source sends out sound waves in all directions as long as there is matter all around the object. So the sound travels in all directions in a longitudinal type movement away from the source. Okay, here we have a pretty cool video. These are this is like styrofoam, and sound is being pushed through it, and as it happens, the styrofoam kind of changes with the sound. It's kind of cool. So what's cool is, like, you can see how the amplitude changes. You can see how the distance, how the wavelength changes. As pitch changes, you can see how the frequency changes in these waves. Very cool visual. If we were to see sound waves, that's what it might look like. Okay? What mediums can sound travel through? Well, really, any state of matter. It's pretty common for sound to travel through, oops, that's not what I wanted to do, for it to travel through air, because that's what we're used to. But sound can also travel through solids and through liquids. In fact, if you ever hear someone in the hallway disrupting your class, that's sound traveling through solids. The sound is coming out of the person's mouth, pushing the air particles in front of it, and then pushing against the wall, and that wall is vibrating a little bit, and that wall then pushes the air molecules that are in the classroom. So sound can travel through solids, can travel through liquids, and can travel through air. So this is showing the vibrations, and this is what a recording of a sound wave might look like. So that's showing a recorded sound wave, what it might look like. And you can see a different amplitude for different volume and different wavelength for different pitches. A quick video showing that sound is just powerful.
The Tacoma Narrows Bridge, banning Puget Sound.
This is a bridge that was built in 1940s. It really only lasted 4 months. It was an engineering catastrophe. What happened was the wind moved through this bridge, and as it moved, it vibrated the bridge at its natural frequency, and you can see
was the third longest suspension
causes
bridge
a
when
lot
it
of
was
movement.
dedicated in 1940.
And as it causes a lot of movement, it just shakes that bridge violently until 4 minutes later it just can't hold up to it and just collapses. So yeah, sound is a powerful thing. It is definitely an energy and can show that energy in destroying things like a bridge. Pretty crazy. This picture, it just shows that different frequencies, and what this is, it's a cloth with a speaker underneath it and then salt poured on top of it, and as the frequency changes, you'll see that the images actually change. That's getting annoying, but you get the idea that as the frequency changes, it realigns where the particles of the salt are moving as the wave changes. Different frequencies, different kinds of waves. So to wrap it up here, you need to make sure that you understand what a source of sound is, and you need to be able to describe what sound would look like as it moved through a wave. If you're going above and beyond, you're able to explain why sound cannot move through a vacuum, why it has to have a medium in order to travel. I'll wrap it up with this video, just a quick glimpse of sound in general, and then we'll be out. So thanks for watching. We'll see you in class tomorrow.
First thing that I need to know, pretty basic, but what is sound?
Sound is a form of energy.
More precisely, sound is a wave of energy that moves away from a vibrating object. For example, a guitar string. It's almost like a pulse moving down a slinky. Check out this sand drum. This is what happens in the air when a sound is created. The source of the sound creates vibrations that shake up air molecules, just like the drum makes the sand and beads dance. As the air molecules jump, they knock their neighbors, and so on until the wave carries the vibration to your ears. So sound is waves.
Exactly.
I get it now.
There's a wave right there.
I hear it. Sound waves.
Hey, Paula, can you hear me?
Todd?
That's right, it's me.
Todd, how'd you do that?
The reason you could hear me down here when I was speaking in the tube up there is that the tube was containing the sound waves from my voice until it came out over here.
I think I get it now. Blue man? So just like the fire extinguisher spray, sound travels from point A, the place where the sound is made. Do it again. To point B, the ear that receives it.